Greetings, welcome in this lesson where we are looking at the science paper 1. Science paper 1, it is physics. This is physics GCE 2024. If you are new to this channel, ensure that you subscribe so that you get the latest updates. I'll be posting a series of questions. If you want to follow these questions, make sure you subscribe and share so that we can reach to so many people. Okay, so our focus is just on section B, which is B7. Figure B7 shows resistors connected to a 4-volt power supply. Okay, so this is our diagram there. This one, it is connected to a 4 voltage power supply. That is the 4 voltage there. Okay, so we need to clearly understand the question here and the diagram. Let's start with the diagram. The diagram there, they have given us on the combined resistance. If you check the one on the left hand side, it's a different connection, and the one on the right hand side, it's also a different connection. So now the one on the left hand side, that is a series connection. Then we have the other one, which is parallel connection. Okay, so we have a parallel connection and we have a series connection. Combine the resistance. So the question is, what is the effective resistance of the circuit? What is the effective resistance of the circuit? Okay, so what they want us to find here is to calculate the total resistance. Of course, we have three resistors here. We have 3 ohms, we have 6 ohms, and we have 12 ohms. Okay, so we are going to use there are two formulas which you can use here. There's one where you combine all the resistors, and the other one. Okay, so we are going to say okay, we can name them. So we can say this is R3. Let's say R3. This is R2, and this is R1. So you can name them any way you want. If you want, you can just say R1, then this one R2, then R3. Okay, so we are going to use this formula. We are going to say R3 plus R1 R2 over R1 plus R2. Okay, so the reason I've done this is because these, they have a different connection. This is also a different connection. So there are two connections here. We have a series connection and we have a parallel connection. So this diagram, it has different connection. This connection is different, and this connection is also different. So we have a series connection and a parallel connection. So we have combined the connection here. Okay, so our R3 there, it is R3. Okay, so we are going to say 3. Okay, 3 plus. Okay, so we can work out this. So our R1 there, we are saying 12. 12, we have multiplied by 6. And then here we have 12 plus 6. Okay, so let's do this. So 3 plus. So when you do 12 times 6 divided by 12 plus 6, what you are going to get is 3 plus 4. So you need to work out this. So 3 plus 4, which is 7 ohms. 7 ohms. So that is our answer. This question was having 2 marks. This question was having 2 marks. So that is our answer there. What is the effective resistance of the circuit? So the effective resistance of the circuit is 7 ohms. That is the answer. If you want, you can use this other formula. You can use this other formula. You can say R3 plus 1 over R 1 over R1 plus 1 over R2. So you can either use this formula or the other formula. Okay, but you still get the same answer. That's how you can even prove if your answer is correct or wrong, by using 2 different formulas. Okay, we proceed. This was a 2 mark. Calculate the potential difference, which is PD, across the 3 ohms. Calculate the potential difference across the 3 ohms. Okay, so we know that the potential difference, which is PD, is equals to IR, current times resistance. So now here we need to be very, very careful. What they want us to find is the potential difference. We don't have the current here. They have only given us the resistance, this one. Okay, so what we are going to do here, let's first find the current. So we're going to say current is equals to we have they have given us what 3, calculate the potential difference of across the 3 ohms. Okay, so we are going to say current is equals to PD. Okay, so we have PD, don't mind my case, I have PD over the total resistance, which is the effective resistance. So you're going to say current is equals to, so our PD there, we have 4 volts, and then the total the effective resistance there, we have 7 ohms. So we are using this formula to find the current. So we are going to say current is equals to, so our final current there, if you punch in the parameters, you're going to get 0.57. So 0.57. The units for current, it is amps or amperes. So that is current. So we have not yet calculated what they have asked us. What they want us to find is the potential difference. So the one we have found is the current. So we are going to come here. So we're going to say potential difference is equals to the total current times the total resistance. Okay, so our total current there, we have said 0.557. We are multiplying by the resistors here, the 3 ohms they have given us here. So you're multiplying it by 3. So when you do 0.57 multiply by 3, you are getting 1.71. So the units for potential difference is volts. So that is our final answer. So 1.71 voltage, that is our potential difference, 1.71 volts. So that is our answer there. So this question was carrying 2 marks. If you check, it was carrying 2 marks. So here we have 1 mark, and also for this one we have 1 mark here. So in case you got lost here, what I did, I just made the subject of the formula by dividing r here, even this other side, dividing r here. That's what I did in case you got lost here, so that it gives me this one. Current, it will be alone, is equals to potential difference over resistance. And then current, we have 4 voltage there, the one they have given us in the question. And then the total resistance, we have 7 ohms. Then when you divide 4 and 7, you are getting 0.57 amps or amperes. So here it was 1 mark. And then now for us to find the potential difference using the 3 ohms resistance, we are going to use this formula. PD is equals to I times R. So R is the one they have given us. So I, we found this one. That is our I there. Current is this one. So 0.57 multiplied by this one. It's the one they have given us here. That is the one they have given us here. When you do 0.57 multiplied by 3, you are getting 1.71 volts. So that is the potential difference. Potential difference is the same as the voltage. So if they ask you calculate the potential difference, they are simply asking you to calculate the voltage. So thank you for watching. If you are new, make sure you subscribe, because I'll be answering more questions. This is just one question. We will answer the next question as well. Make sure you subscribe. Thank you. Then if you have questions, there's a comment section there. You can comment so that we can get interacted. You can comment so that we can get interacted. Thank you so much. Bye bye.